Going on, guys, let's do this problem right here. So the question is asking to calculate the force that Stope must exert on the bottom of the gate to hold the water back. So this is the bottom right here, so let's see how we can find it. So first of all, let's pick up this one and draw separately. So let's say this point is A, right? So what I'm going to do is I'm going to draw this one separately. So if I draw this one, this red part, so this is the point A. So this one, since this is the hinge, this is going to have two forces, AY and the AX, and also we are going to have the force resultant force acting on this side. So resultant force, let's say this acting on this side, and this is going to be FR, and this force that must be exert on the bottom should be against the resultant force. So that's how it can be in equilibrium. So this is Fs, and then we are also going to have the weight of this one. So this is acting downward weight. So these are the forces going to be acting on this part right here. But the question is asking to find this one, force that Stope must exert. So to find this one, we have to first see how we can relate to other forces. So to do that, what I can do, since we have too many unknown, I can eliminate most of them by taking the moment around this one. So if I take moment around A at equilibrium, it's going to be 0. So moment around A is going to be 0 at equilibrium. And from this one, Fr is going to create moment in this direction. So let's say this distance is x. So that's going to be Fr times x minus Fs times the total distance is provided, that is 4 meter. So we can substitute that one right here. That's going to be equal to 0. So from this one we can find the Fs. So Fs is 4. Fs is going to be equal to Fr times x divided by 4, Fr times x. So this is going to be equal to Fs is going to be equal to Fr times x divided by 4. So this is how we find the force that Stope must exert to hold this one in equilibrium. So in this case, to find this one, we have to find the resultant force and the distance that the force is acting on here. So to find that, first of all, we have an equation, P is equal to F over A, and to find the resultant force, I had to rearrange this equation. That's going to be Fr is equal to P times A, but resultant force is going to be equal to average pressure multiplied by the area. But to find the average pressure, we have to find the pressure at centroid. That's going to be the average pressure times area, right? But we don't have the pressure at the centroid is provided, so we have to do another equation. So P is equal to rho gh. So I'm going to substitute that one right here. So since this water rho gh is going to be this density of this water, because we have water right here, so that's density of the water times the acceleration due to gravity times h centroid, the height centroid. So for this one, since this is like a line, so the centroid is going to be exactly in the middle. But from here 3, right, 3 plus 2, so the centroid distance is going to be 5. So this is the HC is going to be equal to 5 meter. So we can calculate this value because we know the density of water is 1000 kilogram per meter cube, and acceleration due to gravity is 9.81, and times h times c times the area. So they have provided the height of this one, but we don't know the width. They haven't provided. Let's assume this is 1. Let's say small a is equal to 1. So this is width. 1 meter. So width is equal to 1. So from this one we can find the resultant force right now. So let's substitute all the values. So 1000 times 9.81 times the centroid, highest height of the centroid from here. So we are using this one as reference point. So 3 plus 2 is going to be 5 times the area. Area is going to be 4 times 1. So from this one we can find the resultant force. That's going to give us 196.2 kilonewton. So this comes out to be the resultant force. But however, the force that is acting on this one is not going to be in the centroid. That's going to be, that's called a center of pressure. That's where this force is going to act. So to find the center of pressure, yp, so this is where these forces are going to act. So to find this location, what I had to do, I had to simply, there's an equation for this, that is yc. So yc means location of the centroid of the area plus ixxc, this area moment of inertia, divided by yc, this is same as this one, that is location of the centroid of the area times the area. So this is a general equation to find the location of the center of the pressure. So we have to use this one to find the x value, right? Since we have found this one right here, this is done, but we have to find the location where this average force is acting to find the fs. So let's find it. So this is going to be yp is equal to yc, that is going to be 5, same one, same height, 5, that's going to be the centroid, and then this is area moment of inertia. So for a rectangular area, the area moment of inertia is I is equal to ixxc is equal to 1 over 12 times base times the height cube. So that's how we calculate the area moment of inertia. So let's substitute that one right here. So it's only half, not half, 1 over 12 times the base. So in this case base is 1 meter, this is base 1 meter times the height, that is in this case it's 4, the total height of this one is 4, so 4 cube, right, cube, and then in the bottom we are going to have this one same as this one, this 5 right here. So let's trace this part, okay, also this one right here, and now this is going to be plus right here, and yc is going to be same as this one, that's 5 times the area is going to be 4 times 1. So we have all the values. I don't know why did I put unit. If I put unit, I had to put it for everything. So 1 times 4 cube. Okay, so now we have all the values. Now we can simply calculate this value. So if you calculate this one comes out to be 5.2667 meter, and that's yp. So we know that from top, the force average force is acting on this location, 5.2667 meter. But from here to here, so I had to, since we are using A as this point, this is the A point, right, A, and since I am using A as this point, what I had to do, I had to simply deduct 3. So 5 point, so from here to here the height is going to be 5.266 minus 3, and that gives us 2.266. So this is the location that resultant force is going to act. Now we have the location and these two informations. Now we can simply calculate that the force that Stope must exert on the bottom of the gate to hold the water back. So these are the all information to find this one. So Fs is equal to Fr. Fr is, we found right here, that is 196.2 kilonewton times the distance. That's going to be from here to here, it's 2.26 meter. 2.266 meter divided by 4. So if I calculate this value, so this is also meter, meter cancels, and if I calculate this value, that's going to be the force that must be exerted by the Stope. So let's see. So if I calculate this one comes out to be 111 kilonewton, and that's the final answer. Fs is equal to 111 kilonewton. This is the force that Stope must exert to keep this one into equilibrium without moving, right? And that's how it's done. I hope you guys like this video. See you next time.